Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session we're going to be talking about resistance and looking at how we combine resistances in circuits. So we'll start off with the following. What is resistance? Right, resistance is simply the opposition to the flow of current in your circuit. So it is resistance, let's put that down. It's going to be the opposition to the flow of current in a circuit. So the best example I'd like to give to kids is going to be, let's say we have this circuit here. Right, current is always trying to flow around and around my circuit. Resistance is going to be the traffic in that circuit, so what's trying to stop that current from going around. So think of resistance like traffic and current like the speed at which you're traveling in a car. If there's a high amount of traffic, your speed is going to be low. If there's a low amount of traffic, your speed is going to be high. So visualize that. Let's just talk about resistance. It's like approximately equal to traffic. So it's like traffic. So if you have a large amount of traffic, you've got high resistance. So if you've got high resistance, therefore we know that the current will be low. Happy with that? Look at I'm just writing it down in short form. If you have higher resistance, therefore the current will be low. That symbol means therefore the current will be low. And if you have a low resistance, therefore the current in your circuit will be high. So once again from the top, resistance is the opposition to the flow of current in your circuit. Resistance is like traffic. So the greater amount of traffic you have, the greater the resistance. Therefore it's harder for you to flow. The lower the amount of resistance, the less traffic there is, the easier it is for you to move through it. Okay, so resistance, that's why I've got a picture of a couple of cars there to show you what traffic looks like. Now, let's try and combine them if we put two of them in series. So, let's say I have two resistors in series and I want to combine them into one resistor. So these two diagrams are equal to each other. Let's say the first one, let's call this resistor 1. Let's call the second resistor resistor 2. Oops, no, not RT. Let's call that resistor 2. If I'm going to combine them together to make the total resistance here. So if I was to redraw that diagram like that, what would be the total resistance? This is dead easy. I simply add them together. So when they're in a series circuit, I simply add them together to work out the total resistance. So R1 plus R2 will be equal to R total. Fairly easy stuff. R1 plus R2 is equal to R total. And then let's put that into context. Let's put some numbers in. So let's just say this is going to be 3 ohms. The other one is 2 ohms. What will be the total resistance then? So R1 is 3 ohms and plus R2, which is 2 ohms. Therefore resistance in total is going to be 5 ohms. So this one over here is going to be 5 ohms. Simple stuff, guys. Yeah, dead easy. Right, now a little bit different, but if I'm going to combine them in a parallel circuit, it's going to be a little bit more challenging for us. So we've got two resistors now in parallel with each other. If I want to combine them into one equivalent resistor, how do we do it? Let's give them a bit of notation. Let's call this one R1. Let's call the other one R2. Let's call this one resistance in total. There's a formula we can use to work out the total resistance. It's a bit long. It's going to be this. 1 over R1, yes, 1 divided by it, plus 1 over R2 will be equal to 1 over resistance in total. So let's put that into context. Let's put some numbers in here. Let's go. Let's call this one 3 ohms as before. This one is 2 ohms. Okay, so let's put the numbers in. 1 over 3. Yeah, 1 divided by 3 plus 1 divided by 2, because that's the second resistor, is equal to 1 over RT. Now, obviously we're going to move on to this side of the board. Let's do that. So we have 1 over 3 plus 1 over 2 is equal to 1 over RT. Okay? So that's going to be, just take your calculator out, I don't really care for this. So it's 1 divided by 3 plus 1 divided by 2, you get 5 over 6 is equal to 1 over RT. Yeah, I'm not going to lie to you, it is a bit complicated. Now, RT is at the bottom of the fraction. You've got to flip it. So just moving that up a bit. Therefore, next bit over here, we know that RT is therefore equal to 6 divided by 5. Make sure you check your maths and how I've done that. Yeah, so I bring the RT up, 6 there, and bring the 5 underneath, ohms. Right, you never leave your answer in terms of a fraction. You always must put it down in terms of a decimal. So it's going to be 1.2 ohms. So RT is equal to 1.2 ohms. Yeah, a little bit more complicated. So as you can see, when I've combined them when they're in parallel, when I combine them, you know, it's very different to when I combine them in series. So when I combine them in series, I get 5 ohms. But notice, if I'm in a parallel circuit, the same resistors, 3 ohms and 2 ohms, I'm getting 1.2 ohms. Okay, now, test your understanding. Which one has the most resistance? So, we've just done it. Let's work out the total resistance of this one. This one, they're in series, so the resistance in total, because they're in series, it's simply going to be 5 ohms, because I'm simply adding the 2 and the 2 ohms together. Oh, sorry, it's 2 and the 2 ohms together. It's going to be 4 ohms. Yes, 2 ohms there plus 2 ohms gives me 4 ohms here. Now, in parallel now, so if we have the parallel circuit, if this one is in parallel, so this is parallel, I've got to use the long formula. 1 over R1 plus 1 over R2 is equal to 1 over resistance in total. Put the numbers in, so it's going to be 1 over 2 plus 1 over 2 is equal to 1 over resistance in total. Now it's going to be half plus a half is 1, therefore 1 is equal to 1 over R total. Flip the fraction, we know that resistance is equal to 1 ohm. Oh, that's a horrendous omega sign. 1 ohm here. So, what does that mean? Look carefully at this diagram. If I put them in series, there's a greater resistance than when I put them in parallel. And that's a fundamental learning fact about this topic. So if I put 2 resistors in series, it has a greater resistance than when 2 of them are in parallel. So, summary for this topic, we've done now. So, number 1, resistance is the opposition to the flow of current. Yes, that's a formal definition. Resistance is measured in ohms. The symbol for ohms is going to be omega. To combine resistors in series, I simply add them together using the following formula. Resistance in total is equal to R1 plus R2. Here we go. To combine the resistors in parallel, I use the formula 1 over R total is 1 over R1 plus 1 over R2. 2 resistors connected in parallel will have less resistance than 2 connected in series. Make sure we understand that. The last point, have a look. When I put them in parallel, whoops, here we go. When I put them into parallel, I'm getting less resistance, 1 ohm, compared to when I put them into series. And that's it for today's session. Oh, I'm zooming in and out, like a crazy person. We can see that we've touched on all these different bits here, and we will need this to tackle more questions on electricity in the future. So, be strong, fight the resistance. Bye-bye.